Okay, for lesson 7, our ICANN statement is, I can use the area model and multiplication to show the equivalence of two fractions. So what you'll be doing is you'll be looking at a fraction, and you'll be trying to find another fraction that is equivalent or equal to that fraction. And to help us get there, we'll be multiplying and using area model. So, looking at this, we see we have 1/3, 1/3, is equal to 2/6. So on top it says, do the same to the bottom as to the top. And we know that the bottom is our denominator and the top is our numerator. So we're going to look at 1/3. What can I multiply 1 by to get me 2? Well, if I multiply 1 by 2, I get 2. And if I multiply 3, I have to multiply, because it says, do the same to the bottom as the top. So if I multiply on the top by 2, I must multiply the bottom by 2. So by multiplying by 2, we create a new equivalent fraction of 2/6. So on this one, it says, how can we compare these fractions? Well, we haven't talked about comparing fractions yet, so we're going to make them equivalent. So how can I make 1/2 equivalent to 4/8? To show that they're equivalent, I know I can multiply the top and bottom by the same number. So 1 times what gets me 4? 1 times 4 equals 4. So I have to multiply 2 times 4 because I multiplied by 4 in the numerator. So now I have 4 in my numerator, 8 in my denominator, which gives me 4/8. And since we're making equivalent or equal fractions, the fractions are equal. Now for an area model, to find an equivalent fraction for 1/4, which we see here, we have this area model, and there's 4 squares. 1 is shaded in. So to find an equivalent fraction, we're going to do something really simple. Draw a line right across the middle of my area model. When we draw that line right across the area model, we now see that we have 8 boxes. And to help us see that, I'm going to use a different color. There we go. Now we can see that a little better. So I drew that right across the middle of my area model. So now I have 8 boxes. Did I change the number of boxes I've shaded in? No, I did not change. So I still have 1 big box shaded in, but now I broke it down into 2 smaller boxes. So now I have 2 shaded in, and I have how many total smaller boxes? I now have 8. So if I want to go from 1/4 and get 2/8, I need to multiply. So this is showing how multiplication, again, shows equivalence. If we divide it in half, then we always multiply by 2. And we see that 1 times 2 equals 2, and 4 times 2 equals 8. Find an equivalent fraction for 1/3 without drawing a model. So we're not going to draw a model for this one. What we're going to do is we're going to use our multiplication. We know if we multiply the numerator and the denominator by the same number, we will get an equivalent fraction. So for example, we've already done 2, so let's try 3. 1 times 3 equals 3. Draw my fraction line. And 3 times 3 equals 9. So we can see that 1/3 is equal to 3/9. Okay. Now we run to our problem set. So on the problem set it says the shaded unit fractions have already been decomposed into smaller units. Express the equivalent fraction in a number sentence using multiplication. The first one has been done for you. So if we look at letter A over here, and we see that we have a rectangle that's divided in half along this line. Okay, it's already divided in half. And I'm going to change my color again. Let's go back to red, since this is in black and white. So it's divided in half. That's why they wrote right here, 1/2. Then they said, well, I'm going to put in this dashed line horizontally, and that divides it again in half. So, and we said earlier, when we divide by, or we divide it into half, we multiply by 2. So now I have 1 times 2, that gets me equals 2, and 2 times 2 equals 4. And if you look, we have 1, 2 shaded in areas, and we've talked earlier when we said numerator was the number of boxes or number of parts that are shaded in. So we have 2 shaded in, and that's over total parts. So we can see that we went from 1/2 and that is equivalent to 2/4. So let's look at B. B, again, we have this rectangle and we just divided it in half. So I'm going to start with my fraction of, give you a chance to think about it, 1/2. Okay. Now, we divided it twice. So now, I can look at it as I need to multiply by some number to give me what? How many shaded parts do I have now? I have 1, and I broke it down into 3. So I know my answer is going to be 3 for my numerator because I have 3 parts shaded in. So 1 times 3 gets me 3. So on my fraction bar, make sure I write them in multiplication symbols. And another equal sign down below. So we're going to do the same thing again. And we said earlier, if we multiply the top by a number, we have to multiply the bottom by the exact same number. Always must multiply the top and bottom by the same. And we can tell that we have 1, 2, 3 parts shaded in. And we have out of 4, 5, 6 total parts. So 3 shaded in over 6 total parts gives me 3/6 for that equivalent fraction. Alright, let's look at this one. Again, what fraction am I going to start with? Because we have a rectangle and we divided it. We've been saying in half, and for some of you, if that's confusing, we divided it into 2, right? So I have 2 total parts. I have this side over here, I have 1. I have 1 part over here, and I have my second part over here. So therefore I have the fraction 1/2, or 1/2. Now we're dividing it horizontally. But this time, we have 4 shaded parts on the left side. So I know that my numerator is going to be 4. But in my fraction bar, 1 times what gets me 4? Yes. 1 times 4 gets me 4. I have to multiply the bottom, or the denominator, what I multiplied the numerator by, or on top. So if I multiply my numerator by 4, I must multiply my denominator by 4. 2 times 4 gets me 8. And again, if you see, we have 8 total parts, 4 shaded in, so 1/2 is equal to 4/8, or 4/8 is an equivalent fraction for 1/2. And D. Again, we're going to start with 1/2. If you haven't noticed the pattern, we're starting with 1/2 every time.
Nothing, huh?
Starting with 1/2. So continuing with what we have here 1/2, because we notice the pattern, they've all been 1/2 so far. Because and when I say a pattern, I mean notice that we're just dividing it into two pieces, the bigger rectangle into two pieces. So I'm taking this rectangle and I'm just dividing it into two pieces. So it's just dividing it into two pieces again. And this time they divide it into 5 going horizontally. So you can see the dashed lines. So we can see that. We can see that there's 1, 2, 3, 4, 5 parts on the left side. So I already know my numerator is going to be 5. Then I also know that I can put in my multiplication symbols. And I need to do 1 times what gets me 5? Well, 1 times 5. On the bottom, I have to multiply by 5 again because I did it in the numerator, so the denominator must also be multiplied by 5. So we get 5/10. The biggest thing that you need to understand for making equivalent fractions is that the amount of stuff that you have is not changing. The amount of stuff doesn't change, okay? It is how you divide it up is what matters. So think of it as you have a pie, okay? For example, we have a pie. And let's look at this one over here. And let's divide this pie. Right? So I divided my pie into 8 pretty equal pieces. Okay? Now, it doesn't matter. I still have one whole pie. So whether I divide the pie into smaller pieces or not, I still have the same amount of pie. So let's look at it. If I shade in 1/2 of this pie, I shade in 1/2, did I not shade in 4 pieces of the pie? So all I did was take that half a pie and broke it down to 4 smaller pieces. So it's still the same amount of stuff, but it's just written in a different way, or breaking it down into smaller pieces. Okay. Now, this one, and we're just going to do a few because, again, we should be getting pretty good at this. So if I break this down, and it says decompose the shaded fractions into smaller units using area models, express the equivalent fractions in a number sentence using multiplication. Okay, so we're going to do, let's go down to D, because we've kind of touched on fourths and fifths already, so let's go to D. Well, let's look. I have 1, 2, 3, 4, 5, 6, 7 total squares. Okay? So I have 7 total squares. So I already know that my original fraction is going to be 7 in my denominator, because total squares, or total pieces, or total parts, is always my denominator, my total. Fraction bar. Now, how many do I have shaded in? I have 1 shaded in. So my fraction is 1/7. Now, I draw this nice horizontal line, as we've been doing earlier with the dashed lines. And again, if we divide it in half or into 2 parts, I have an upper part and a lower part, I now know that I can multiply my top and my bottom by 2. So 2 over 14. So 1/7 is equal to 2 over 14, or 2/14. I could divide it into 3 parts, 4 parts, 5 parts, 6 parts. But the point is, if it asks you to find the equivalent fraction, find the easiest equivalent fraction you can. Okay. What happened to the size of the fraction units when you decompose the fraction? They got smaller. And the total number of units went up proportionately to the numerator.